Hi again, everybody. I'm here to share some more helpful or intermediate strategies when you're working on your graph software Connex project. So to begin, I've started us off with, you may have guessed it, a little Mickey Mouse shape, and it looks like he's missing the other ear. And we talked about how it's helpful to make your project symmetrical about the y-axis. That way it's easier to find the equation of pieces that are symmetrical. I wanted to also share this trick. So this right here is the equation of the ear. You can right click it and click copy and then right click paste to have another version of that show up. And then when you open that one up, if I just change that x plus 2.7 to an x minus 2.7, right, that's all I had to do to recreate that symmetrical version. So I have this Mickey Mouse shape, and I wanted to talk about outlining a little bit because some people ask me, does shading a shape and then putting the outline around the same shape count as one or two equations? So it actually counts as one inequality and one equation. So what I'm talking about is, let's say I paste this again, but instead of making it fill in the ear, I wanted it to be the outline. I would make this an equal sign and probably make this black just because outlines typically tend to be black, right? So that is now an equation. The pink part is the inequality. So that's two things instead of just one. So if I put an outline on all three of these, all I have to do is really copy and paste. Change that inequality to the equal sign, change the color, and get the other one as well. That's not how you'd want this shape outlined. You'd love it if this overlapping piece here and here for each ear would disappear. So I'm going to show you how to do that. And this would occur not just for outlining, but if you were drawing some type of shape where you'd want one shape to stop and another shape to pick up where you left off. And that's actually really easy to do. You don't have to find the intersection or like restrict the domain or range and do that by guessing. You actually can just use the equation of one of the shapes as a restriction on the other. So let's say I took this ear to the left and I wanted it to stop when it hit this circle. I would use the big circle as the restriction. I'm going to actually, hold on. I'm going to open up the equation. I'm going to copy that. So I just Control V'd. So I'm opening up the left ear, this one right here, and I'm going to paste in that big circle constraint. So now if I just hit OK, you'll notice it goes away, right? It's not just that simple. We have to do a little bit of playing around. We definitely want this to be an outline, right? So we want this to stay in equals, but we want only part of it to show up, and we want the part that's outside of the big circle. So if I change this constraint's inequality something like that, you'll notice that I just stopped this one from showing up over here. That's perfect. So I may also want this part of the big circle to also disappear, right? So let's go into the big circle's outline. Oh, before I do that, I should copy the equation of the left ear. Now I'm into the big circle, put that one in here to this constraint, and this time I want, sometimes you just play around with it. You could even like just do this, like put an inequality, see which, oh nope, that's not the part that I wanted, it's the other part, right? I think you get what I'm saying. It really is like a guessing game. There's not many options, right? But you could also think about it. So there we go, that's exactly what I wanted to happen. But I would also need to repeat that on the other side. So on the other side, We're going to do the same process. I'm going to open up the equation of the right ear, which is this one. Notice how I just click on things to check that I'm copying the right equation. And I'm going to go back into the outline of the big circle. Now, since this one already has a constraint, if I paste in something else, the computer's not just going to understand what I've said. I have to put another word in here. So if I type the word and, it's going to do both of these things. And we would like this to shade outside of the right ear as well. Let's see if I did that right. Perfect. So that part's gone. And like I said, I really just used the word and to connect constraints. So if you had more than two, you would just connect all of them with ands in between them. It's totally fine. I'm going to finish up this ear. So now I need the equation of the big circle and paste that into the constraint of the right ear. And we want the part outside, and there we go. So the last thing I wanted to show you is that you can make a constraint through a shaded region that isn't something that you typically might think of. Let's say I wanted to slice part of Mickey's chin off here. Now, that might be easier to do with another shape right on top of it, but maybe that's not the easier thing for your particular situation, right? I feel like our projects are so individually decided upon. So I just wanted to give you an example here about a constraint that might not even be something that you want to show up through an outline, but just part of it that you'd want to disappear, right? So you can put whatever equation you want in here. Let's say I wanted that line to have a negative, let's say like a -1/2 slope and go through y-intercept at -2. Right? If I type that in as an equation, nothing's going to satisfy that constraint now. But if I typed it in as an inequality, that's going to constrain my shading, right? So now this is saying shade above that line. And I mean, I just thought of one reason you might want to do this. It just created a stripe within Mickey's head, right? Like the outline is still there, but now there's this stripe, and maybe once we get rid of the grid and the axes, that would be white. Maybe that's something you'd want. I don't know. But don't forget, we don't just know about lines, we also know about parabolas, right? We could make this a parabola. We could make multiple constraints in here. I could do and y is less or less than 0.5x minus 2, right? So look, now both of those constraints together make this shape that doesn't even have a name. Maybe that's the shape you were looking for in the first place, right? So just remember to play around with this. You're going to get weird things, and that's okay. That's how we are going to learn how to get this project done. And don't forget to, once you're trying things on your own, if you need help, ask your teachers. Good luck.